Fine. So good afternoon. Today we'll see knapsack problem. Okay. This is one of the technique under again the greedy technique. Okay. So before we start knapsack, I'll just give you an example. Okay. Say these days lockdown is happening. You are going to a market. Okay. So what you have is a bag. You have a sack is nothing but a bag. Okay. In the bag you are asked to fill the items. Okay. The bag has a maximum capacity. Okay. And you are having different items with different weights, means each of the item is having its own weight, and if you buy each item it will get you its own profit. Okay. So your idea is to maximize the profit. Okay. And whenever you are filling the bag, you cannot exceed the capacity of the bag. Okay. So that is about the problem. I'll give you one more example. Your capacity of the bag is 10 kgs. Okay. You have three items. Say cotton is there, rice is there, say, and then wheat is there. Okay. Three items. If you buy rice, it will give you more profit than wheat. Okay. And then cotton, if you buy the profit will be less. So in that case, you will try to fill the bag with maximum rice because it will give you more profit, isn't it? So that is where the problem of knapsack arose. And knapsack is one problem which can be solved by using various techniques. So the first technique is greedy technique. Later, for the same knapsack problem, we will apply dynamic programming technique, and again the same problem can be used by using branch and bound. Okay. So the problem is same, techniques are different. Now we will see, and this is also one of the optimization problem as I told you. Okay. So now we will see how to solve this problem. Before solving the problem, we will see to definition of this knapsack problem. What is this knapsack problem? Okay. So just you have a look at the statement. We are given with n objects and one knapsack. Knapsack is nothing but a bag. Number of object is n. Okay. And you have some ith object. It has the weight wi, and total capacity of the knapsack is capital M. Okay. And see, if you are taking the item as a whole, then you will represent that by 0, 1 knapsack. Means 0, 1 means if you have taken the item completely, it represents a 1. If you are not taken the item at all, that is represented by 0. Okay. That is 0, 1 knapsack. But in this knapsack problem, whatever we have taken, a fraction of the item also is allowed to take. Okay, you can take a fraction of the amount also. That is also allowed. Okay. So if a fraction xi, where xi lies between 0 and 1, of the object I is placed into the knapsack, then the profit pi into xi is earned. Okay. The objective is to obtain a filling of the knapsack that maximizes the total profit earned. Okay. This is, as I said, it is a maximization problem. And since the capacity is m, we require the total weight of all the chosen objects to be at most capital M. Okay. That is, we have to maximize the profit. Maximize pi into xi, summation I lies between 1 to n. 1 less than or equal to I, less than or equal to n. This is the problem statement. Maximize summation 1 less than or equal to I less than or equal to N, Pi Xi. Subject to, this is the constraint, that is Wi into Xi, which is less than or equal to capital M, which is the capacity of the knapsack. And this lies between, again I lies between 1 to N. And 0 is less than or equal to Xi less than or equal to 1, and I lies between 1 and N. These are the conditions. Okay, I repeat, you are given with the knapsack. Knapsack capacity is capital M. Okay, and small n is the number of objects. Okay, so small n is the number of objects, and each of the object, it is having its own weight, its own profit. Okay, if you take that, say for example Xi, a fraction of it if you are going to take, then what is the profit earned? Pi into Xi. And what is the weight? It is Wi into Xi. This is the constraint. If you are taking a fraction of that, the weight into Xi, okay, it will be the Wi Xi is less than or equal to M. So this is how the knapsack problem is formulated. Okay, say for example you have 3 weights, the maximum capacity is 10. Okay, and you are having 3 items, one is of weight 5, one is of weight 3, one is of weight 2. Okay, 5, 3, 2. So what is the total capacity? 10. First what you will do, you will take the item with maximum weight, that is weight 5, put it in the bag. Okay, it has got its own profit. Now what is the remaining capacity of the bag? 10 minus 5. Why? Because the total capacity of the bag was 10. Now you have already added 5 kg to the bag. The remaining capacity is 10 minus 5, which is 5. Now to fill the next item, you will have to see the remaining capacity, and then you will have to see which is the item that will fit in that remaining, capacity of the bag. This is how you progress in the problem. Okay, and again like yesterday, there are so many feasible solutions. Out of the feasible solutions, one will be the optimal solution. Which is the optimal solution in our case? The problem which gives us the maximum profit. Okay, that is the combination of items which will give us the maximum profit. That is going to be the optimal solution. There will be so many feasible solutions. Which are the feasible solutions? The solutions which will fit the condition. Okay, which will satisfy the condition and the different items which we are going to put in the bag. Those will be the feasible ones. Out of all the feasible ones, the one which is going to give us the maximum profit, we say that is the optimal solution. Okay, our job is to maximize this profit, that is Pi into Xi. That is the aim of solving this problem. Now a feasible solution is any set x1 through xn satisfying 4.2. What is 4.2? Subject to the constraints summation 1 less than or equal to I less than or equal to N of Wi Xi. Okay, which is less than or equal to M. Fine. So if at all this condition is satisfied, then we say the solution is a feasible solution. This is about the summary of knapsack problem. Now we will have to look at one problem. How to solve this? Consider the following instance of the knapsack problem. This is ordinary knapsack. Okay. The other one is 01 knapsack. In 01 knapsack, we are going to take the item as a whole, or we are not considering the item at all. Whereas in knapsack, a part of the item, a fraction of the item can be considered. So n equal to 3. That is total number of items we have is 3. Capital M is 20. Means the maximum capacity of the bag is 20. Then the profits. There are 3 items. If you take the first item, profit is 25. Second item will give you 24. And third item, the profit is 15. What is the weight of each of it? It is W1 is 18. W2 is 15, W3 is 10. Okay, so these are the weights. Now, how do we solve this problem? There are 4 feasible solutions. Okay, so in all the cases, okay, the weight, each one of it, it should be less than or equal to capital M. Okay, the weight is less than or equal to capital M. It means whatever item we are filling in the knapsack, it is not going to exceed the total capacity of the knapsack. Okay, now we will consider each solution. Say here, look at the profits. P1 is going to give us the maximum profit. Okay, so P1 will be 25. Now what we will do? We will choose this P1 and then I will put it to the bag. Okay, I have taken P1 and then I have put it in the bag. Now what is the weight of it? Weight is 18. Okay, weight is 18 and I have taken P1. Its profit is 25. What is the maximum capacity of the bag? Bag capacity is 20. I have already put a weight of 18. What is the remaining capacity? 2. Okay, so remaining capacity is 2. Now next item what I'll do is, next item will give me more profit, isn't it? So I will take the second item now. Okay, and third item I will not choose at all. But what is the capacity? 2 kgs is left. What is the total capacity? 15. Out of 15, I will take 2 kgs. So that is 2 by 15. Okay, and what is the weight? Weight is, initially I took 18, then from here I took 2. So total is 20. Okay, and what is the profit? This is 25 and total profit would have been 24. But I have taken only, 2 out of 15. So the fractional value, finally you will get 28.2. If you take this part of it, so it is 25 plus I think 3.2, that will be 28.2. Okay, this when you are going to do, when you are choosing the highest profit first, you are going to choose the highest profit first, then you will choose the next highest profit. In that case, you are going to get this solution. Now, what if you arrange the weights in the increasing order and then choose the highest weight? Okay, if that is the case, what would have been the solution? That is the second part of it. The other way of solving is, you will choose in such a way that you are going to see this solution. Okay, the weight you have taken, that is, if it is 10 kg, this complete 10 kg you have taken as a whole. Okay, and what is the remaining weight? Remaining weight is 10. Remaining capacity of the bag is 10. So out of this 15 kg, you have taken 2/3 of it. Then profit would be so much. The Wi into Xi is this much and the profit is maximum here. Okay. In this case, what you have done, you have taken the item 2 separately. That is full item 2 you have taken. Item 2 will give you a profit of 24 and it is having a weight of 15. Okay. Remaining capacity of the bag is 5 kgs. Total capacity is 20. You have already taken 15. So this is first item you have not at all taken. Second item you have taken fully. So 15 kgs you have taken. remaining capacity is 5 kgs. So 5 means 10 is the total weight. You have taken half of it. Half of it is 5 here. So this is 0, 1 and 2, and you calculate this WIXI and PIXI. These are the values which you get. So out of all these values, solution 4 will give you the maximum profit. Okay, so for each one of it, you have applied the different strategies. What are the different strategies? First, you have tried to arrange the profit in non-decreasing order. That is, you take the highest profit first and then the next highest profit. So you have tried to choose the item which will give you the highest profit first. That is one method. Other method is you are trying to get the highest weight first, and correspondingly you will get the corresponding profit. Third method is you are going to take the fractional value. Okay, you are taking the fractional value of the item, and even the profit become fractional of that. So you have considered these 4 values. Out of the 4 values, the last solution gives you the highest profit. So these are all the feasible solutions. Why all are feasible? Because all are satisfying the condition, that is m equal to 20. So in all these cases, the weight we have taken is less than or equal to m. Nowhere we have exceeded the maximum capacity 20. So out of all these feasible solutions, the last solution is the optimal solution. So this we call it as the knapsack problem. Okay, the method is explained here and the algorithm goes like this. Yes, what is the complexity of the algorithm? It is big O of n. The complexity is big O of n. Now let's look at the algorithm and what is the procedure to solve this greedy knapsack. Okay, so in this greedy knapsack, we are going to send profit, weight, maximum capacity of the knapsack, and different x, that is the fractional value of the item chosen. N is the count, total number of items. As usual, we have 3 comments. Profit P of 1 to n, and this is weight of 1 to n. This is the input. Contain the profits and weights respectively, and then the objects are ordered so that you are going to take the PI by WI ratio. Okay, the last option in the optimal solution, what we have done, we have taken, I told you, we are taking the fractional value. So PI by WI we are taking, and then we are increasing that in the increasing order of PI by WI. Then we are going to choose a fractional value of this. So Pi by Wi is greater than or equal to P of I plus 1 by W of I plus 1, so on. Okay, so we are going to arrange all the items. If there are 3 items, we will check P of I by W of I for each of the values, and whichever is the highest, the one which will give the highest profit, we are going to store it in the first place, and that we are going to consider for the knapsack problem. M is the knapsack size and X is the solution vector. Why is this X of 1 to n is a solution vector? What part of this item we have taken, that is given by the X array. So this X vector indicates the solution vector. Okay, so here he has declared all that as real, because we cannot store fractions in the computer. We will have to solve that fraction and then bring it to the form of a real value. Okay, so we will have to save it as a fraction, decimal value. Now X is 0, Cu, you are going to make it, M is stored in Cu. That is the remaining knapsack capacity. Remaining knapsack capacity, because once you load the item into the bag, the total capacity minus the weight of the item would be the remaining capacity of the bag. Now, for I is 1 to n, do if W of I is greater than remaining capacity, if the weight what we have chosen is greater than the remaining capacity, we cannot consider that item, isn't it? So, exit. Otherwise, choose that item. That is, 1 you are going to put it in X of I. And then Cu is Cu minus W of I. If you have taken that item, what is the remaining capacity? Remaining capacity minus weight of the new item. Okay. This process you repeat till you complete all the items. Then once you come out of the loop, if I is less than or equal to n, it means you are not considered some of the items. Then xi is cu by wi. You end it. Else, go back to greedy knapsack. So this is a recursive process. So this is how the greedy knapsack works. Okay. So this is about greedy knapsack.